A class project is valuable as it fosters practical application of knowledge, enhances teamwork, time management, and problem-solving skills. It nurtures creativity, hones presentation abilities, and mirrors real-world challenges, preparing students for future careers while building a tangible portfolio of achievements. A good project blends into your course of study. It should be the coexistence of gaining knowledge and its application in a specific context. In this short video, a few project ideas are mentioned, but please understand that many different project ideas are possible. There really are many product categories to consider, from basic technology all the way to simulation or even understanding the role of wearables in promoting activities of daily living. Please find a project that you will find rewarding. It should not be like pulling teeth or something you regret undertaking. Spend a little time thinking about how the project can be beneficial to your career. We'll look at a few ideas once we mention the role of project teams. Project groups are neither encouraged or discouraged. Some project topics are more suitable for teams than others, and again, even if a team could be formed, don't feel you have to. It's okay to go it alone. A few things to think about, however. In more complicated, multifaceted project teams, members with complementary competencies can be quite productive. It is important, though, that you have a team that can work together and have a balance of effort and say in the project plan and executions. One more thing about teams is the benefit of making decisions when compromise is required. Let's take a quick look. Often, projects face dilemmas, and a group can be an asset in that case. For example, conflicts over the need for hard data versus working on an intuitive basis can be challenging. Maybe the data is simply not there to be had. As well, your product may involve some ambiguity and the need to focus on specific, possibly difficult, goals versus being flexible and adaptive to a new project aims that may involve some discussion and debate. As well, is the project going to leverage your core competencies, or is the team interested in learning new challenges? In these situations, and decisions are sometimes easier to manage as a team than if you are solo. Let's look at some project ideas. Consider some project idea areas related to contemporary issues in technology today. In the area of prevention, suppose we could establish genetic predisposition to injury. This might involve analyzing an individual's genetic makeup to identify potential vulnerabilities or susceptibles to certain types of injuries. By understanding an individual's predispositions, healthcare professionals can develop personalized injury prevention strategies, such as targeted exercise plans and lifestyle modifications. This approach can significantly improve quality of life by reducing the risk of injuries, enhancing overall physical well-being, and enabling individuals to make informed decisions about their activities and habits based on their genetic profile. The scope of this is clearly beyond what could be explored in a full semester, but as a minimum, it is a catalyst for several project ideas. Nanotechnology offers utility in creating advanced materials with enhanced properties, such as increased strength or conductivity, by manipulating matter at the nanoscale level. Furthermore, it holds promise in developing artificial tissues by precisely engineering biomimetic structures that can replicate functions of natural tissues, leading to breakthroughs in regenerative medicine and improving all medical treatments. A bit far away from tissue biomechanics, but again, this could be a catalyst for some ideas. Case studies in forensics is another area with many potential projects. If these contemporary perspectives do not seem very tractable, let's turn our attention to the rapidly growing area of tissue simulation. Projects in simulation encompass a range of applications, including using simulations as complements to traditional laboratory experiments and modeling. Simulation serves as a valuable adjunct by providing a controlled environment for testing hypotheses and scenarios that might be challenging or impractical to replicate physically. Additionally, large databases play a pivotal role in training simulations, enabling the development of robust and accurate models through exposure to diverse data, ultimately enhancing the simulation's predictive capabilities. Furthermore, simulations, such as those conducted with OpenSim, facilitate parametric studies. In the context of a case study, OpenSim allows researchers to explore various parameters and their effects on a system's behavior. This approach aids in understanding complex interaction and optimizing outcomes. By integrating simulations, laboratory experience, modeling, and data analysis, projects can achieve comprehensive insights and advancements across diverse fields, from medicine and engineering, leading to more informed decision-making and innovative solutions. The unreliability of wearables and simulation today stems from several key issues. Firstly, there's a lack of standardization in sensor accuracy and data collection methods, leading to inconsistency in measurements. Additionally, wearables can be affected by external factors such as motion artifacts, sensor placement errors, and environmental conditions, which can introduce inaccuracies into the simulated data. Moreover, the limited lifespan of wearable sensors and batteries can impact the reliability and longevity of simulations. Finally, integrating wearable data into simulations often requires complex data processing and validation, which can introduce errors if not managed carefully. These issues collectively challenge the trustworthiness and effectiveness of wearables in simulation contexts. So indeed, many projects in tissue biomechanics derive from the general issue of wearability in assessing human performance. In summary, the best project is one that can help meet your needs and actually create an enduring understanding. Maybe the project is simply the start of a journey. You might end up saying to yourself, gee, I never realized X, Y, or Z. Maybe the project inspires you to take something to market, right? Even the simplest prototype can help you see the future, maybe a new product. Possibly the project helps build a foundation for further work, whether it's a thesis, dissertation, future classes, or even work in industry. Many of the ideas already discussed have been suitable in prior years. These projects reflect a lot of creativity and reflect the diversity of topics and the application of tissue biomechanics in this class. So please undertake the formulation of a project with a degree of intention for your investment to pay off for the course and in the long run. Stay in touch and reach out with any questions or issues.